Hi everyone, good evening. My name is Oded. I work for Pivotal, a company that brought you Spring, so I think you're all familiar with the things that we do. I want to talk to you kind of like, I think it's a good progression from what Dave just mentioned in his talk. How do you really take that concept and move it to a production environment as soon as you can, right? How can you take something that you have in your mind, you have like an idea that you want to develop, and you write it in your IDE or whatever, and it works great, and you test it on your laptop, and it works great, and then you want to get it to production, right? There's a lot of things that you have to think about when you go through this journey, right? So we're all developers here, so we're not always thinking about these things. We're trying to like keep some sort of like silo sometimes between us with ops and dev, and you know the whole DevOps. The whole DevOps revolution is trying to get us better connected to one another for that. But it is really, how do you get from your code to production? And there's really a lot of things that you have to think about when you do this type of journey, right? When you take your code to production. There are things like routing that, you know, we don't want to really think about as developers. Just like Dave said, you know, it's like below the value line. I don't really want to think about things like routing. I don't think about observability. I mean, I really want to use observability. I don't want to start setting up observability infrastructure. I want my app to run in containers, but honestly, I'm not really interested in like writing containers. It doesn't really give me much value. If my JVM version of my Spring version is not really something that I want to think about when I'm writing my business code, a Docker file and from base image of whatever operating system I'm going to use, that's definitely not something I want to care about, right? It's really things that I'm trying to get away from and focus again on my business logic. Things like Jvm Optimization, things like that, right? So these are all things that in the end is your responsibility or your organization's responsibility in a way, right? The things that you have to take care of. So I want to talk about, you know, if you looked at those like 4 slices in Dave's talk of like IaaS, and then you have a container as a service, which we all know as Kubernetes these days. That's like the standard. And the 2 additional platforms in a way is the platform as a service and then the function as a service. So we spend the first part talking a lot about serverless and function as a service. So I want to focus about the platform as a service for these 30 minutes. And really, what I'm trying to say is that all these things should really become a platform's responsibility, right? You want to take as little effort from your side to get something working in a production-like environment, okay? So I'm going to do a demo, if the demo gods will help me. I want to write a simple application, like a to-do application, okay? So that's the app I'm going to try and write. Hopefully we'll get it ready in time. I will cheat a bit with autocomplete due to time constraints, but that's what we got to do. And I wrote a few of the things here on the screen just to, like, as we go along, maybe like check boxes off and see if we're really getting to that really like production-like environment that we think about. Okay, so we're going to write a to-do application. It's going to be based on front-end written in Vue.js. We're going to talk to a back-end written in Spring. Spring will talk to a metrics system. It's going to write to MySQLDB, and it's going to send events to Rabbitmq for analytics down the line. That's not ambitious at all, is it? Okay, so let's start with our code. And if you ever saw our friend Josh Long's talk, you already know that we always start at spring.io. So I'm going to write an application. I'm going to write an application that's called to-do service, right? And I'm going to need quite a few dependencies. And again, it's very nice to have this talk after Dave's talk, because think about the number of things that you need to add, because these are not coupled in your application, right? This is a web application. So you do need a lot of things in your dependencies, right? So I'm definitely going to need web. That's one of the things I'm going to need. I'm going to write to a MySQL database. So I'm going to write it, take the MySQL database driver. For testing and desktop development, I will want to use an in-memory database. So I'll use H2 for that. I want to integrate with a metric system, and in Spring we use a Spring Boot actuator for that. So I'm going to add that to my dependencies. It's going to expose a lot of very valuable information about my application to me. I'm gonna use Spring Cloud Stream. And again, Spring Cloud Stream, as been said before, it's just an abstraction layer over all kinds of message brokers, right? So it can be Rabbitmq, it can be Kafka, it can be an Amazon provided, Google's PubSub, whatever it may be. And you can just, at configuration, or really at compilation time, based on your dependencies, decide what kind of runtime you're gonna talk to. So I'm actually going to try and switch between them. So I'm going to add both Rabbitmq and Kafka to my dependencies. So that should be fun. I'm sure that's going to work. Because I'm talking to a database, I will use a Java Persistence API. I will use Lombok. Who is using Lombok, by the way? Good, 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 good. We reached the good location in life. And I'm going to use REST repositories because I really don't like to write a lot of boilerplate code. So that's all my things. These are the things that I need to generate. It's right here. I already have it just as a baseline here, already published, so it's the same type of base dependencies, right? So it's just the main application right here. So I'm going to start by defining an entity, just a JPA entity, and we're writing a to-do application. So I'm going to write an entity that is going to be called to-do. Can you see that, by the way? Is it looking okay? Cool. I'm going to define an entity called to-do. I will use Lombok again because I really don't want to start writing getters and setters and constructors and all of that. I will add a no-args constructor because I'm using JPA and the framework requires that in the reflection. And my data type really has 3 parameters. It has an ID, which is a generated value. It has a title, which is basically the name of the task. And it has a Boolean saying, is it completed or is it still an uncompleted task? So that's great. So, you know, with Spring Data and with the integration with JPA, that's pretty much all I need to do in order to get something modeled to work with a database eventually. Now I want to expose it as a REST endpoint, right? So I can obviously start writing, you know, REST controllers and all of that. And that's really useful sometimes when you really want to start adding your own type of custom implementation. But I really like the integration that we have with the repository REST resource, because that really exposes for me pretty much 80% of what I need out of the box, right? So this simple interface line gives me a to-do repository, which is basically a REST exposure to the JPA, right? So it already defined the JPA repository for me. It tells me that my primary key is long and my value is a to-do, right? And I already get all the CRUD operations out of the box. I didn't have to do anything. I don't have to write like my getter and my post and my put and my delete and implement all of these boilerplate type of activities. It just gives it for me out of the box. So that's really great. I think that's enough for like the initial part of the application. Let's see if it works, right? That should be interesting. So let's run that. Let's boot our to-do service. Should start up here, hiding. All right, so we seem to be running. Now, because I'm running locally, I don't have any MySQL database running, it's just going to pick H2, right? Again, Spring, one of the main benefits is just auto-configures to whatever you have. When you have it, it's going to auto-configure to that. So I have my application running. Let's see, localhost 8080. No, okay. I have configuration. Let's keep it for the sake of time. So I have in my application properties already a few configurations defined, right? So some of the things are already configured in advance is just a context path. So I told it, please base the entire application under the base context path with /API, because I want to have it a more type of well-defined type of integration. So my entire application is running under /API. So I already have the application up and running. I'm using, Hiatus to get all of this type of metadata about my endpoint available to me. It's all just coming from me out of the box. I know that I have a to-dos endpoint that I can use. So if I'll click here and I'm going to remove this and just have to-dos, I'm going to see all my information about my to-do application. There is 0 elements right now, which is not surprising at all. So let's try and add one, right? So let's do post to 8080/API title equals hello RL, right? Almost, yeah. /API /todos title equals LORL, and it brings us a response that my application has been created. I think you can barely see that, can you? Jesus. So I posted an endpoint, and it gave me back a response. I can see it here now as well in my JSON, right? I have it here. I have links built in. I didn't have to write anything to get that working for me. So here's my first one, ID equals 1, hello RL. It's not completed. Everything works as I expect. That's great. So another thing that I have, again, because I set a dependency on the actuator endpoint, is that I have all of these actuator endpoints available for me out of the box, right? I also added in my configuration that I want to expose all of them, which is usually, you're not going to do that in a production environment, but for demos it's really cool because you get all of these endpoints open to you that you can play with. So the amount of data that I get here is really crazy. You can think about checking that and using it in any type of monitoring application. So for example, I can see all the beans that are currently running in my Spring Boot application. They're all here, right? I can go over them one by one, read it, and then fall asleep. I can, for example, go and check the health of my application. It's telling me, yeah, you're good, you're up. So that's a good endpoint to use, especially in the Kubernetes world, if you want to ping something and make sure that application responds as you expect. Another one that's very useful is metrics. So metrics really gives me like internal information about the JVM running, and I can use that to do a lot of things. For example, if I want to check the current max memory of my application, I can request that. It will tell me I have about 0.5 GB running with all of the dependencies that I downloaded before to my initialization. So all of these things, again, very minimal code, just a few dependencies, and I get that. So now what I want to do is really just add another one of these endpoints to the metrics, right? So it's really nice that I get like I can know how many connections are in my connection pool. It's great that I know what my max JVM memory is, but it would be very useful if I can add my own gaugs, like to know, for example, things about my database or my own business logic, right? That's very useful. So I'm going to try and add that. Let's go here. So I'm going to add two things. First of all, I'm going to expose, by default, when we're using the REST repositories, it does not expose the IDs, and I'm going to use that later on. So I want to make sure that when I get a response from this configuration, I can expose the generated value, the annotation of the ID of to-do class. That's one thing. Secondly, I want to add a Micrometer endpoint, right? So let's see what we have here. So it's a configuration bin, right? I'm injecting the to-do repository that we created earlier. And I'm defining a bin that is a type of a gauge. So that's a counter, a to-do counter, that is going to inject the registry into this particular method. And it's just going to give me a value called todos.total that's going to return the number of rows in my database, right? A very simple type of use case that you can think of where you want to just tell me how many records are currently in the database. So that's what it's going to do. So I'm going to restart this application. Let's see if we have it now running in our app. So that's restarted. If I refresh here, 3, 2, 1 should be available. So we have todos.total now. That's another metric that I have now in my application, and I can ask it how many records are currently in my application. Obviously I have 0 because it's using in-memory database. It restarted, so I have none. If I'll post again and I'll refresh, I'll see that I have 1, right? So that's really great. So my application now has some better monitoring. I can add all kinds of business logic type of monitoring that I want to use. I'm talking to a database, still H2, which is fine, right? One thing that's missing from that that diagram that I'm seeing here is really I want to send a message to Rabbitmq when I'm doing something. So let's add that. I'm going to go here and I'm going to add one last item. And that's something that allows me to override activities before performing all kinds of operations on the database, right? So that's a repository event handler, right? And a repository event handler has all kinds of handlers that I can do. I can do handle after create, handle after delete, handle before save, etc. All kinds of operations that I want to perform that are tied to my JPA operations in the JVM, right? So here what I'm doing, I'm just handling before saving, and I'm saying that if the to-do is completed, if I'm marking it as completed, please send a message to the message broker, to whatever is running in Spring Cloud Stream, right? Do we have a source? A source is basically like something you send events to. Look at that. Dave Sawyer, can you see that? Do you know this guy? Have you ever met him? Yeah, so he wrote Spring Cloud Stream, and he's there, and he's here. That's really cool. So what I'm doing basically is just saying that I'm basically binding this particular application to a source. It's like an abstract channel, a generic channel that I want to use in my application. And I'm telling it to send messages, basically the title of the to-do, into that particular channel. Now, where do I really define the channel? Going back to a question that was here prior, it's just in my configuration, right? So if I go here and let's say that I have Spring Cloud Stream bindings and an output channel, and this output channel, let's call it completed tasks. That means that at runtime, it's going to output to a topic called completed tasks if I'm running on Kafka, right? If I'm running on Rabbitmq, it will output to an Exchange topic called completed tasks. If it's in Google PubSub, whatever their implementation may be, right? So I should have Kafka running here. Let's see if that works. Yeah, I should be here. Yeah, so I have Kafka running here, and it's listening to a topic called completed tasks, right? And now what I'm going to do, if I restart this application with the updated code, when I'm updating one of these tasks to be completed, it should just send a message to that topic in Kafka, right? So let's see if that works. I'm going to go here, and I'm going to once again create, let's create another endpoint. All right, so I created a task, right? And now I want to just update it and say that it is marked as completed. So let's say this is called meetup and completed equals true. Okay, so that's been updated, and if everything goes well, I should see in my consumer that a message meetup arrived at my Kafka topic, right? So the streaming works. So again, Dave mentioned it actually before, that what if I want to replace message brokers between environments? How hard would it be if I'm doing it using Spring Cloud Stream? Well, to be honest, all you really need to do is just go here and say, yeah, now be Rabbit. Okay. So now I replaced my entire application from running against Kafka to running against Rabbitmq. Now let's try to prove it, otherwise demo gods would laugh at me. So localhost 15602. Again, we share the same password, Dave. Don't tell anyone. Exchanges, right? So I have a completed tasks topic here, right? And if I'll go to queues, there is a queue running here. First of all, let's show there's nothing here. So there's probably messages from before. Server has 0 messages, right? So that's great. Let's run again. So I'm going to create an event, and I'm going to update it to completed state. Great, so that's done. Let's see here, get messages. Yeah, look at that, meetup. So that worked, right? So we switched from Kafka to Rabbitmq by replacing 5 characters in our configuration. That's really nice. Okay, so I think that's pretty much it from the things that run on my laptop, right? That's really cool. I did my development. I wasted a lot of time in debugging. I obviously did TDD. Everyone writes JUnit tests, right? I mean, you're all writing unit tests, I'm sure, right? That's obvious. I didn't even have to mention that. That's like a given. So from this point on, I really want to start running it on some production environment, right? And again, going back to that PaaS model, the idea of a platform as a service is really to give you as little to worry about as you can, right? So you've got your Spring Boot application, it's running on your laptop. I want to take it and do the exact same thing on my production environment, right? That's kind of the haiku of the Cloud Foundry project. Cloud Foundry, for those who don't know, it's an open source project. It's mainly contributed by Pivotal, but used by many, many companies around the world, many vendors. It's really probably the most successful platform as a service, especially for enterprises in the world today. And what it's really giving you is like, just take my source code, run it on the cloud for me. I don't want to take care of all of these things that are here, right? That I sometimes have to take care of myself. So in order to run my application, first let's build it again just to make sure that it's fully compiled and everything is good. In order to take it and run it on my production environment, which as you can probably guess, I said beforehand, all I really have to do, one of the things that I really don't like is YAML-driven development and four pages of YAML just to get an hello world running. So I always like to say that, you can use minimal YAML with Cloud Foundry, but no YAML is even better. So I can do things like this, for example, right? This is the command that I need to do to get my application containerized, packaged, routable, observable, optimized for JVM, ready for auto-scaling, ready for integration with data service. All of these things that I sometimes need to take care of myself, I can do with a simple command. So the command is cspush. I'm pointing it to the jar file that I just built. I'm telling it, similar to what I did locally, that I want to look at the route path called /API, and I'm calling the application to do service. That's really all I need to do from my end. What's happening now is that I'm uploading the bits to the platform, and the platform is going to start streaming back information back at me. Okay, let me show you what I'm doing to containerize the application to make sure that it's ready for a production environment, right? So I already have the route available. As you can see here, it already told me, here's your route. It's not going to return anything at the moment because I really don't have any application running there, but it's there, right? It's a 404, that's good. So it looked at my code, it finally figured out, yeah, these are all the build packs, which is like an open source technology that lets you generate containers based on best practices, right? All kinds of templates and things that are really been tested in the wild in production in many organizations. So it figured out automatically that because it's a jar, I'm probably going to want to run the Java build pack. That makes sense. Now it's going to start calculating all of these JVM parameters that are usually, not really fun to do, right? You need to calculate your class memory or the region and all of that. All of the things that you need to do to make sure that everything runs correctly. Especially in containerized environments, the ratio between the JVM memory and the container memory can become really important. And there's an actual step here that says, let me calculate the memory for you. There's a memory calculator that does it for you automatically as you're as you're pushing your application, right? So it created this droplet for me, which is kind of like an image. You can think of it like an image. And I'm just waiting for our application to start. And once it's going to be finished with that and the application will be up and running, we can see if it works. So it's now running. That's great. I didn't have to write any YAML to get it running, which is always a good thing. I'm trying to make it smaller specifically to show you the Java start command that it created for me, right? So I think we can definitely mark down the Jvm Optimization here. So it took away everything related to the Jvm Optimization and took care of that for me. Obviously, I can override things if I want to. Sometimes you probably want to. But this is a very production-ready type of way to run my workload, right? So if I go back here and I'll look at this Apps Manager dashboard, which is like a nice GUI for the Cloud Foundry platform. Cloud Foundry, in a way, you can think of it as being separated in concepts of like orgs and spaces, right? So in every organization, which can be like your project, you can have multiple spaces like dev, test, production, whatever it may be. So I'll go into the dev space, and there's a to-do service here, which is we just deployed. And if we'll have a look at the things that happened in the application so far, so we have the app being created, received a route, and it started, right? That's all the events that I currently did. I can have a look here and see that it's running. So the container tells me, yeah, this process is running, the container is running, which is really great. I can even view the app and see that I have the same endpoint as before, only this time I have a routable URL, which is really nice. I think we can remove routing from here. So we have routing working and load balancing. I mean, I can scale it up and down as much as I want, right? I can say, please give me 3 containers instead of 1. So it's going to create 3 additional 2 containers behind the scenes, and it's just going to round robin between all of them and give me the same endpoint as before. So that's great. But this is very interesting. If you look here, the container told me that it's running, but the actual application told me that it's down. Why is it down, right? So, once you move from the container as a service to the platform as a service, part of the things that you really want to get is, better observability, right? So the integration between Spring Actuator and the platform lets us know that the Spring itself, the application, is telling me, look, something is not right, I'm not ready yet. And if I look deep down, I will see that it's telling me I cannot connect to Rabbitmq, right? So I don't have Rabbitmq connected in this platform, so I can't really say that I'm up and running as expected. Even if you look at the database, it's telling me, yeah, I'm connected to H2, so I'm up, but honestly, I'll probably want to connect to a production MySQL database instead, right? So let's fix that. So to fix that, there's a marketplace in the Cloud Foundry ecosystem with many vendors supporting that. I installed just a couple of services here. So I have MySQL. I can choose a plan that tells me, like according to the environment, and then I can have like a small plan, a medium plan, a large plan for production, things like that. I'm going to call it just a demo, and I'm going to click create, right? So that's going to go out and build a MySQL database for me. I already created it beforehand because it could take like 5 minutes, so that's a lot of my 30 minutes. I'm also going to create Rabbitmq. So that actually is very fast because there are pre-provisioned options. So I'm going to choose Rabbitmq. I'm going to choose the plan. And I'm going to call it Rabbitmq, right? So that's been created. So now I have a MySQL database and I have a Rabbitmq message broker available to me. Now, how do I attach them to my application, right? That's the main question. So again, going back to the ideas of Spring and auto configuration, the question was actually raised during Dave's talk as well, where just it was able to talk to Rabbitmq and it didn't configure anything. How did that work? Well, that's because the default implementation in Spring is to look for localhost 5672 unless you change it, right? So usually you can use things like a configuration server to change that type of default behavior to like other things, or just change your application properties, whatever you want. But another thing that's becoming a very useful use case, and it's being used by practically almost everyone nowadays, is the concept of the Open Service Broker API, which became a standard for everything from Kubernetes to Cloud Foundry to just like any vendor that you can think of that really gives you the ability to attach backend services to your code, right? Just a standard way to make this integration a lot simpler and not bind your real working code with things like the actual URL and the username and the password. These things should not be in your code ever, right? That makes no sense. That's not production ready. That's how you leak credentials to production and then someone calls Niv in the middle of the day and tells him what's going on with my application, right? So that's exactly what I'm going to do here with our application. Everything I'm showing in the UI is obviously done in continuous integration pipelines or in command line or in REST, but it's nice to demo in the UI. So for this application, I just want to bind 2 services, right? So the services I want to bind is the MySQL database. And the other one I want to bind is the Rabbitmq, right? And that's it. So I'm going to restage this application, basically tell it, start the process again to find out this new configuration at runtime. What it's going to do is just going to inject environment variables to the application, right? Now, Spring and .NET, by the way, if there's .NET developers here, is able to auto-configure itself based on these Open Service Broker API environment variables. So I don't have to write any configuration in my code to connect to these endpoints, right? So if I go here, and in a second it's going to restart, what I'm going to see here, hopefully, is that my 3 containers are now reporting that they're up and running. Everything is good, everything is green. I can connect to MySQL, I can connect to whatever I want. Let's see, hopefully. So it's still starting. Let me refresh this. So one of them is already up. and it says that it's up, right? Everything is green, I'm connected to Rabbitmq, I'm connected to MySQL now. Everything is working as I expect. So that's great, my application is running. Another additional thing that I get out of the box because I'm using a platform is aggregated logging, for example. So I can see all of my logs here, which is really nice. If I have 10 containers, I will see them in the same location. Again, integrating with the framework level at a path layer is the ability, for example, is to change my logging level, right? So if I have an issue in production, I want to understand what's going on with this Kafka config, right? Let's move it to trace level for a few seconds and see what's going on, get some logs without downtime, obviously. And once it's done, I'm going to put it back in error stage and then I can continue. So that's very useful to do like monitoring and debugging. Tracing, if I want to see like the last API calls made to my application, I can see them here, very useful. If I want to get a thread dump of my application, I can download it or just look at it at a JSON type of format here. All of these things to do like very basic type of monitoring I can do right out of the box, which is very, very useful. So, okay, I think my backend is done. Let me push my front end here, which is gonna be really quick because I'm not gonna write a front end in front of you. I'm not good at front end, I'm sorry. I have just a Vue.js application here. I'll just for a quick second show the API JSON. All it's really doing is talking to the same URL as the window it's at and calling the /API endpoint, right? So I have create, get, update, and remove. I'm just performing these activities. Now again, to get this running on my platform, this is a Node.js application. This is not even a Spring application. All I really need to do is configure some sort of a manifest YAML. I don't even have to do that, but it's useful to do that. And here I'm just pointing to a Node.js build pack, right? I'm just saying that I want to build a container of Node.js. I'm giving it a parameter of a production for Node environment, and I can push this application out to my platform. Same concept as before, just CS push it. It's going to take the bits, going to upload them to the platform, and once it's done, I'm going to have the application up and running, and I'll be able to talk, hopefully, between my front end and my back end. So while it's doing that, I want to go back here and look at my backend application. And as you can see, there's a nice button here called View in Pcf Metrics. So View in Pcf Metrics basically tells me I want to get from my platform also a much better observability and the ability to see all kinds of interesting parameters and information about my application. So what it's doing now, it's going to, hopefully, once it finished spinning, there you are. Where have you been? So what I'm seeing here is really just like the baseline type of information that I get about my application, right? So I have information like average request latency, requests per minute, CPU utilization, things like that I really want to know about. Very nice is the ability to integrate the logs that happened at the same time, right? So I can see the logs that happened at that particular point where I got this spike, and now I'm able to get better correlation about my application, which is really nice. Now, something that is really very useful, as you remember before, we added these actuator metrics, like JVM and what it may be, but we also added our own endpoint. Remember that? We added an endpoint called to-dos total. So that's exposed here as well, and I can just add that as another one of the parameters. So now I have a parameter that tells me basically how many records are currently in my database. And it tells me I have around 4 records in my database, right? So that's just a gag that I can use whenever I want without making any changes to my code. So let's see if our front end has been deployed. It's going there. The crashed is probably the funniest type of UI interaction because it's crashed because it's not running yet, right? That's the initial state of a container. If it's not running, it's crashed. There's nothing in the middle. So the application now is going to finish in a second. About 20 megabytes of upload. It took it a while. That's why it takes a bit longer. Once it's going to be up and running, we're going to be able to communicate between our front end and our back end, and we'll be able to see it running. Let's see. Yeah, so it's in the final stages here. Just like before, it created the artifact, it created a container, it's found a place to run it, and now it's waiting for the app to start. So in 3, 2, 1, the application will be running. Yeah. So there's my application. It's now running. it received a random route because I told it to for a reason. So if I click it, I'm going to see that application now in my web browser, but it's going to tell me that I cannot load the to-dos. Now, why isn't it able to load my to-dos? That's because I defined in my application that I want to have the same fully qualified domain name for my front end and my back end, right? As you probably saw in the code. So to fix that, I'm just going to change the routing here, and I'm going to say that I want to have the exact same route for my front end, and my backend is mapped into a different route path with /API, so it will know exactly where to route each one of the requests coming in to each application, right? Oh, that one already exists. Let me route to an existing one. There it is. So now if I open it, yay, it works. So I have my front end talking to my backend. I have my to-dos running here. That's really nice. I can add other, right? Yeah, so it added it to my database. Everything is working. I have my front end, I have my back end. That's really, really nice. One last thing I want to do is I want to be able to have my backend scale according to load, right? So just like Niv said at the beginning, it's nice if you have everything running like immediately and everything is always highly available, but that's very wasteful, right? I want to be able to auto scale based on use cases. So there's the option to manage auto scaling based on all kinds of rules. I can auto scale based on trivial things like CPU or memory or Rabbitmq depth, but I want to scale it based on a custom rule. I want to scale it down if it has less than 6 records in my database, and I want to scale it up if it has more than 10 records in my database, right? That's what I want to test here. And I'm going to give it the same parameter that we defined. It was to-dos, was it to-dos or to-do? That's a very important distinction. To-dos, yeah. To-dos total, right? All right. So now I basically told my application scale between 3 and 6 based on the parameters that the number of records in the database. So let's start adding records. You can join me if you want. You can pull out your phones because it is a production environment, as I said, right? You can go to this link. It's available. You should be able to see it quite nicely, actually. We try to make it running nice on phones. So if you go to to-do.pvtl.dev, you should be able to see the same type of application that I'm seeing right here, right? So I'm just going to add a few records. And remember, if we bypass 10 records here, we should be able to auto-scale our application automatically. Don't write anything nasty, it's being recorded, right? Promise me. So 9 items, hello again, hello there. Let's see, we have 11 records here. Don't delete things because then it's going to remove. Okay, so there are around 12 items here. If I will start refreshing my application here, these things usually take about 30 seconds because it's not going to start auto scaling up and down just in like a spike of like a few milliseconds. Hopefully what we're going to see now is that we're going to have another container suddenly up and running and saving my application based on custom metric that I threw for my application, right? That's a very, very nice activity. Let's leave it running here for a second. Due to time constraints, I'm just going to push the last application in the background while we wait. And that's our final analytics application. It's running right here. Now this is a Spring developer meetup, but I'm doing something quite wild here. I'm pushing a .NET Framework application running on Windows containers, God forbid, right? This thing doesn't even compile on my laptop, right? It doesn't work on a Mac. But I could just send the bits to my platform and let the platform build the container for me because it's a platform. I don't have to build the container in advance. So it's going to build it and it's going to create it behind the scenes. It's going to run a Windows container. Hey, look at that, starting. 4th container is running because we passed the threshold, right? So that works, that's really nice. I got my auto scaling just as I expected. Now I'm getting the Windows container up and running. It should be up, yeah, there it is. And let's see if our messaging works, right? So what I have now is a Spring Boot application sending to Rabbitmq and a .NET Framework application running on Windows receiving these messages. So that should be our final test for our running application. Let's see. In the meantime, let's just verify that it is a Windows container. I'm going to SSH into completed tasks, which is the name of the application. And it should give me a C prompt on my MacBook Pro. Oh my God, what is going on here? Yeah. Have you ever had a container with pictures folder? No. This is my application running in a Windows container side by side of my Linux containers in the same application. There it is, it's up and running. If I'll click receive, I should probably get nothing now, makes sense. But if I'll come here, refresh, and let's say, call mom has been done, call Frank, get milk, write a blog post. Let's refresh. Yay, look at that. Great, so that works. So I think that concludes my test. Let's see if I got everything. So I have logging, that's great. I have observability, we saw that. I got containerization. CVE patching is just out of the box because the platform builds the container for me, right? So every time I'm pushing the code, I'm getting a better container. We saw auto-scaling. We saw data services being bound to our application, and we even saw legacy integration, which every enterprise has. So I hope that was useful. Sorry for the time. I think it was a bit more than half an hour.
Thank you.